Okay, that's not possible. Can't have an unused unless previous -5 would be the first one. So let's say, well, actually, I meant it like that. Let's just make this previous -6. Circular buffer. So current keeps overriding stuff, and then so we wrote this one and then that and then that, and then it wrapped to the beginning, and now we're here. Now assume that well, in this case total number of samples can be anything. I don't know, 10. Let's say all samples equals just have to get this one as well. The only way. Or just discount. That is easier, isn't it? The number of relevant samples cannot be negative. And this can be at most, this is positive, so it can be the smallest number is 0. The largest sample is size, that the number of relevant samples in the buffer can be at most the size of the buffer. Then we subtract from that a non-negative value. Which basically is the number of relevant samples. No. This is just this is the number of relevant samples, which is always positive, so I don't need the standard min. Yeah, but okay, I still do a maximum though. Need some kind of limit on it. Maximum of size, and that cannot be larger than size. Oops. And the number of not relative samples is size minus that. Good, so if we don't have any relevant samples, then we don't do the while loop. Otherwise we do it at most the number of not relevant samples. And then I want to start at current minus the number of relevant samples. No, it's actually not true. I mean, it wouldn't make a difference, but it is. This is a better expression, I think. Now, if this became negative, then the max did kick in, but in that case, this would be equal to size, and therefore this would be 0, and we wouldn't enter the while loop. Therefore, we're not using I. I can be negative anyway, by the way. So it's hard to test it anyway, but this is the better way, I think. Then you have to convert I back to a history index. Well, the easiest way would be I percentage size if I is positive or not negative. Cast it to a history index. But then I must make first sure that I is positive. How the hell do we do that? I guess I should use this value then. Then I know that this is at most size. Therefore I is at most minus size. Okay, suppose it is the first one. I just want to increment it. No. I need a count. I need to update old samples, I think, by decreasing old samples with the count. And count is then equal to well, I don't know, something that increases every time we get here. +1, I think, so I might as well put it there. So. And my microphone is still closed for some reason. Yeah, okay, so. I'm having a shitty day. Now I know why I opened it. And it still crashes at the same place. No, that didn't work. So I'm calling it with the sample at 2.7, which is correct. And then it should make... Oh, wait, this is 1. Well, anyway, 5 is current. So then we go back. 4, 3, 2, 1. Then we found it, and we should make all of these current again, except 0. And even that does not happen. So, I mean, I don't want that to happen. I only want 5 and 1 to be current. But the way I wrote it now, it should make everything except 0 current, and it's not. Why? So let's make a breakpoint in here and see what the hell is happening. The current is 5. This is index 0, index 1. See, this 1 is indeed at 2.7. Oh, it is numbered. The labels are equal to the index. So 5 should be at, well, let's count it. This was 1. Index 2, 3, 4, 5. Yeah, so that is 4.1. And of course, previous equals to 4. And we have 6 old samples. And the total number of samples is 6 as well. So everything is old, basically. Now these are only not even used yet, so we simply started filling it from the front and then went all the way till here. No, okay, that makes sense. So 1, 2, 3, 4, 5, 6 in total. Number of relevant samples in the buffer should be 0. And that is the case because oh fuck. Yeah, okay. 9. What the hell? Wait a minute. Is something not right? No, wait a minute. First of all, what? I did not execute it yet. Next. I think that's 9. What? How the hell is? Why is it 9? Total number of samples. Oh, this is the size. Yeah, I thought the size was 6. Size is 9. So the max is complete bullshit. It should have been min. I want to clamp on size. No, find a breakpoint back. Might as well do that again. So the number of relevant samples is now 0, and the number of not relevant samples must be 6. Not next, print. 7. What is that? I think this kind of I need a min or max here as well. But the way this is done, you would say that if this is 0, let's subtract 0 from size. It should have been 9. What the hell? Size is 9. Number of relevant buffers is 0. Therefore, this is 9 minus 0 is 9. What? Well, it was decremented here, but only once. Don't tell me I already went around to loop. No. Maybe I did. Excusez-moi. 0. Next. Print. 9. Okay. But it isn't 9 because these three are not initialized at all. They are not used. So it can be at most the total number of samples. So it would be the standard minimum of this and the total number of samples. And should fix that as well then. 144. I'm doing it again. And I missed the mute button. Okay, that's current. So if current is equal to sample, but it's not, because sample is the nearest sample, nearest to current. And now count is 2. And the annoying thing is that now I expected it to be equal, but it's not. So we keep adding stuff until we do find it. Still not. Dude. Oh, that's bad. What the fuck? I is not changed. Ah. Yep. Very good. How many bugs can you make in 50 lines of code? Yeah, I don't want I to become negative, otherwise the modulo might not work correctly. So I'm going to add another size then. And then we can just decrement I. The end of the loop. Now it should work. Now it's not equal. Still not. So that was 4, right? So this is 3, 2, and this should be equal. I is now 1. Sample is that value, and the address of that is the same thing. So yes. Making 5 old samples relevant again. This is not what I want. Maybe I should just find it and then swap it in the history array. Swap 2 elements so that this one is now immediately before 4. So the 4 is current. Sorry, 4 is not the current. This one is the current. This is actually 5, I think. And then the previous one is this one, which has label 1, but then is stored in index 4. I don't think the order is very important. Oh, actually it is. I swapped that stuff, then my pointers get invalidated. And I'm using pointers to these things. forget it. Okay, I'm going to do it completely different. This is not working. That means forget the make relevant. It was going wrong somewhere. Why? It was going wrong in handle local extreme. Where I'm looking for the number of relevant samples. Probably not. Yeah, it is relevant samples. So I think that maybe instead of running over all the history samples, I should just run over all the samples stored in the approximation. Basically, that's the same thing. I mean, I run over all. I'm trying to run over all history samples that are relevant, but relevant means that they are part of the current approximation. And I invalidated everything in the history. Then I added 2 samples back to the approximation, but not to the history. So this is going to say, well, no, there are no samples, but we do have samples, 2 of them, in the approximation. Why not use that? On the other hand, it says, I'm trying to find all usable samples. So maybe I should run over all relevant samples in history, and additionally to that, anything in approximation, because the approximation only stores 2 samples, and I'm looking for 3 samples. So I can do this, and then also use the approximation samples, because they might not be in the history or might not be relevant anymore. Diablo, Google it. There's loads of nice YouTubes about it. So I want to add one more, being the non-local extreme from the approximation. And that one more I could hide under I equals 0. And then I'm going to have to work with the pointer because I need to change it. So I need to get a sample from the approximation that is not the last one that was added, if it exists, but it must exist because I'd rather add an assert because I have the feeling that it just really should exist. So I'm having approximation pointer and then get my info. Okay, approximation pointer is a pointer to an approximation which has number of relevant samples. So I want to make sure that the number of relevant samples is at least 2, which you can access. I can just call previous, baha, which already asserts it. Now, I'm not sure if it is not in the history, to be honest. That would definitely not be the case if the history is always reset. But then I don't have to look in it anyway, and this code used to work before, so it's not always reset. Yeah, no, I mean, it could be. I think it could be in the history. Yeah, so that means that we just get twice the same pointer. So that's easy to detect, and I definitely should not use that again then. So I have to remember if it came from the approximation. So I'm going to have a sample const pointer. Let's call this the approximation sample. Initialize to null pointer. Well, I don't have to initialize it because the very first time we initialize it here. Might as well. I'll do it the other way around. Sample becomes approximation sample. Yeah, we skip it then, if it is, if we already process it here. Now this should give me the 2 samples, come on. Oh no, it doesn't. Mwaha. The extreme isn't even in the approximation. Sorry, in the history. Huh? Yeah, that should be. Okay. Revisit. Oh god, where did I edit it last? The only thing I could remember. Oh, horrible. Okay, so in fact there's 2 samples that you might want to use. So we can run for -1, I guess. Why? Wait. I do not want. Oh my god. Wait a minute. I do not want a local extreme. This should already suffice then? Yes, I think so. Oh, yes, it does. Never mind. This is going to work. Let's just run it directly. So what happened? Oh, that's shocking. No, I need one space more. Okay. I just found this minimum. Of course, sorry. I just found this maximum here. Fits the 4th degree polynomial, and it's going to jump to this minimum because it's lower than that one. It needs, however, this the value, and the derivative is horizontal, of course. But well, you don't know that yet. Maybe it's maybe the fit doesn't. The 4th degree polynomial does not fit the real function. It does. It's exactly on top of it, but well. So I press space, and then we get those values. These values. So the 4.17 is the minimum. Yeah, that's 0.5 here. And that is added to the history. Now we try to update the scale of the previous extreme for some reason. So belonging to the maximum. But the fit that we had for this maximum does not fit this minimum. I don't know how it was, but something like well, I don't know, maybe it's going up or down, so its deviation is too big. So this return disconnected, and therefore the scale and the history are reset. So we kind of start over with our approximation, which is cool because, well, we had an approximation around this point here, and now we want to have an approximation around this point, so we should start over. But the start over then begins with an approximation that includes that new point, of course. I mean, that's just this point. And as well as any point that is closest to it that we still had, which happens to be 1 by coincidence. 1 could also not exist. I mean, it could have come from here and then found that point. In which case it would have been the maximum itself. But the closer to 5 the better, so we find 1, add that to the approximation, and then we have this approximation, the magenta one, going through 1 and 5. So we do find 1, but the history is still empty, basically. So then we go to, now the scale is updated for the minimum, so we have a scale. Not surprisingly, that approximation returns the same value, because the derivative there is 0. So whatever we fit through it has a minimum right there. Okay, so now I call find extreme for those 2 points, 1 and 5. And we want to find a minimum. Yeah, I'm still not sure that this is the minimum. This is just the minimum of the fit through this maximum. But I don't know what the real minimum is. So we're looking for a minimum on the right of point 1. So not on this side, but on that side. Using 1 and 5. And that then happens to be 5, because it does fit. Not 100% on top of it. It's that much off. So we're returning now this instead of that. But pretty much on top of it, yes. I mean, it's like 5 digits the same, which is immediately detected, and therefore we say, oh, we're already there, and the minimum has been reached. And therefore now we call handle local extreme. So now it's going to handle the found minimum. And not enough debug out. I'm not happy with this. Why is it still 0? So I expected this to be 1 now, because it's going to look for samples within the scale range around 0.5, meaning, and the scale, I mean, the approximation is made with 1 and 5, which makes the distance from 1 to 5 to scale. And the scale range is then 1.1 times that distance, so definitely including 1. Therefore, the number of usable samples within the scale range, excluding the local extreme here, is 1. That is 0.1 itself. But it doesn't find it. I'm afraid we have to debug this, because I think this is unexpected. How often do we get here? It's the second time. Can you just set a breakpoint and then continue once? Oh, no. Now you're already there. I want to see how it is calculated. Yeah, I think I need a breakpoint here, of course, and then continue once. So delete all breakpoints, set the breakpoint there, run from the start. Continue below. Now we're there. Handle the 4.1 seventh thing, which is the minimum, right? Next, this is true. Add it to the extremes. Okay, so, oh, yeah, okay, I'm an idiot. This is 0, we don't even enter the loop at once. Man, so stupid. So I expected to get here anyway, but yeah, no, not gonna happen. Yeah, since it's the first time, might as well do this outside the loop, or however, then we can't do this. So I kind of have to, this symbol always exists, now I think about it. Do we want to enter at least once? At least once, right? Yeah. It's not very clear code, but it is easy to fix anyway. Might as well make a do while of it then. It must be negated. How do you do that? No, that's negated, I guess. Yeah, larger will never happen, so I'm changing this into an equals. The continue here now is a little bit dubious. Because I also want to increment I, so I might as well increment I here at the top. Just started -1. Duh. Well, I broke it. This used to be 3. Now it's 1. How is that now possible? Just keep screwing up. I guess I screwed up my while then. Yeah, Jesus Christ. And nobody said something. I feel so stupid these days. Unbelievable. I had no idea why I did it. Negating that Boolean expression was nonsense. 100% pure nonsense. And we stop again. Mm-hmm. Oh, okay. Now one more, I hope. Mm-hmm. Hmm? That's the same one as the previous one. So I was not incremented. Oh yeah, right. There's another continue and I have to increment it as well here. Okay. Maybe the whole while loop was not the best idea. Yeah. Yeah, okay, we're back at 3 here, and now we have 1 here. So, progress. Okay, so now I'm just going to hit a space, I guess, and we crash. Ugh. Yeah, this should have been 3 now, or 2. Sorry, it should have been 2. Why is it not 2? Yeah, I'm getting why it is not 2. Getting tired of it though. So the reason it is not 2 is that the first time around we had an approximation based on 1 and 5. And approximation stores only 2 samples, the 2 samples that it is based upon. So we could find 1. And then we find that we still have 1 sample to view, because we need 3 samples for the 4th degree polynomial. So it adds a sample there. And adds it to the approximation. I just should not do that, but I think that that's what happened. So this point has been added to the approximation object, and therefore kicking out that one. Kicking out? Yeah, this one becomes previous, this one becomes the last one. Then it's not even the way I want to store it, actually. It's horrible. I did add it to the approximation because I'm using the approximation samples to find the nearest sample. So let's say after this we find out that there is no maximum in the 4th degree polynomial on the right, and there we want to just continue. So we do a step, and the step ends up here. And then I want to make a new approximation together with this one and the one that is the nearest, the same as we did here. And then I want to find that 0.6 here that we added. And since it is looking in the last approximation, the approximation around 5, it wants it to be in there. But if I don't add it, so I still have 1, we will find 5 and not 6. What a mess. Let's begin not adding it. So that would be this comment and this add. So then the get near sample would fail, which is kind of silly because I'm calling it immediately afterwards. I might as well find the nearest sample and then check if the sample that we have here is not closer. It would have the same effect. For now, I'm going to not do this. But if I don't do that, I don't know if it disconnects or not. Okay, so you're not going to do this whole thing. Still. Okay, run it again through this function at the same point. So this is the same as previously. So we're going to find, okay, it stores it, updates best minimum, and last extreme, and validates that, and then we're going to find the number of usable samples, for which we find this one, because that was 0.1, which is added, and then we find nothing anymore, because the history is empty. So now we have one of them. So the number of usable samples is less than 2, therefore we just do a step in the horizontal direction, and adding a 5.6. Well, going to request that. Need extra sample, status extra sample, return true. This is very tiresome. Can I break this GTA? No, I cannot. Break algorithm or something. So now we enter for the extra sample, and this is true. And we insert that before current sample. It's actually scary, because it does invalidate the pointer to the current one. Is that a problem? Probably not. Let's see, we can see what happens exactly. Yeah, so this is the minimum, that is current, that is the 5th entry, I think. Index 0, 1, 2, 3, 4, 5. That is current. And now we run that. And I see that the 5.6 is inserted in between these two. So, okay, that works. Current is now pointing at 6, previous at 5. Looks all fine to me. All samples did not change, and the total number of samples is 1 larger. However, that means that only the last one is relevant at the moment. And so here none is relevant, and now there is 1 relevant, but that 1 relevant sample is current, not the one that I added. That is kind of strange. Probably should have incremented all samples to 7 as well. Still nothing is relevant. But okay, yeah, okay. insert before current. Let's continue. The critical point is still 4.17, and this is then going to count. Yeah, this should find. Oh, wait a minute. Yeah, well, yeah. My new point has not been added to either now. Not to the approximation, neither to the history, so we cannot find that one. That is stupid, of course. I should add it to the history. Wait a minute, no, I did add it to the history. This is a new point. It was added to the history. But it's still not a relevant sample. So it's still not found. That is the reason. But okay, the other one, which is at 2.7, this one, is not in the history at all. So we really want to find that one still in the samples. Maybe you even should make all samples 5. Make this one relevant and that one. Boy, oh boy, oh boy. It's not clean code. Okay, this one is added. Yeah, that's 0.1. So that does work, but it's just not finding the other one because I'm not storing it. I am storing it in history, but what to do? Revive make relevant. Or just make it relevant when I insert it. Well, now it's 2. And still a crash. On the same crash, assert on the same thing. This, however, is perfect. Did we not have that before then? Oh, now I'm confused. I did all this trouble, went through all this trouble to see all these samples. What was the problem, the previous crash? Ah, yes. So it was fitting a 4-degree polynomial, otherwise you would never get here. But it used 2.7 twice. Ouch. That should never have happened, of course. Why did it happen? I need to reproduce that. So I change back what I just changed, and now I want to have a breakpoint here, which is the how many times handle local extreme was called. 1, 2, 3. So yep, that was reproduced. So now run it in the debugger. Break here. Run. Continue twice, I think. So this is the 1, 2, 3rd time that we get here. And what I wanted to test was why we get twice 2.7. So the first one is the approximation sample. Oh! Oh! Wow, yeah. Tja, tja. Okay, yeah. I can't compare the pointers between the history and this one, because approximation makes a copy, I think. Oh, wait a minute, now I'm not sure anymore. Does it make a copy or do it just store pointers? I think it actually makes a copy. So the pointers are in different periods. What the hell is it? What the hell is that? A X7 FFFF? That would be a sample on the stack. Surely approximation pointer is not pointing to the stack. No, it's not. Super confusing. No. Okay, anyway, then we go to the history. And there's only one. What is this? This is even worse than I expected. Did I miss that here? The last crash said this. Yeah, there's only one. How the hell can it use 3 points when there is only one found? It's even worse than I thought. Well, it's less than 2. Okay, less than 2 are found, and then what the hell happens? His state is unequal. Oh, but it isn't. State is equal now. And then we do that, and then we... Oh! Oh, here it happens. Now we are adding the same thing as we already added. Yeah. This should add the current sample, which I only have in the history. Probably a previous one. Yeah, then it doesn't even make sense to insert it before current. So we're not using the history. If I now want to kind of plug it out of the history, I might as well use current here. And then adjust this as I did before. Well, we should have enough asserts. Can't make any mistake in an assert virus. Of course this is negligible, because these are the same. I'm not even sure what I was trying to test there. This is the... what? Okay, I think I know what to do. Okay, so I'll explain it again for the new viewers. This is a fourth degree polynomial. It's just a test function. It could have been anything, but I picked a fourth degree polynomial. The downside of that is that we have an exact fit. At the moment I fit a fourth degree polynomial, but okay, we're not testing anything related to that anyway. We just start anywhere and we're trying to find the global minimum. Anywhere being, well, there. And at that point we have both the height, which is not very interesting, except for we want to minimize that one, and also the slope. The rest is invisible, yeah? So what is a logical thing to do? Well, the logical thing to do is, because you look for a minimum, is to go downhill, which means looking at the slope to the right. But how far? You could add 1,000,000. There's absolutely no way you can know that. Absolutely no way. So there is a random thing called learning rate that is then multiplied with the derivative, and yeah, we might as well use a random generator if you ask me. I set that pretty small, so we get all the way there. Well, that's not small, but then again this scale is pretty small compared to what I sometimes have. It's not insanely far either anyway. Now we can fit, well, a parabola, but I'm going to delete it from the code. I want to switch completely to cubics. So we can fit an exact cubic through point 0 and 1. Exact being that it both goes through both points and as well as has the same derivative in both points, which are both known, right? For the parabola, that's not the case, and you can not fit parabola that goes through both points and also has the same derivative. So that is less accurate, actually. Of less accurate, I mean, you have to throw away some data. It's not important. I'm going to delete that anyway. That was another attempt. Now, based on this approximation, we still don't know what the curve is. We just have 2 points and derivatives, and this is the best approximation that we can make. And based on that, I'm gonna say, let's go to the maximum. Why? Because in between 0 and 1, that's here, the maximum is closer than the minimum. So it's more likely to be precise. And hey, I have proof of that here on my screen, because it is pretty much correct. Well, this one is super far off. There is no maximum, no minimum here at all. Okay, there's that one, but you see what a distance. And this is almost already on top. So that decision is correct. Okay, so we jump here. And now using this point, of course, we have a much better approximation. Now we see that the minimum is a little step more further to the left, so we do that as well. And then it says maximum reached. So now it knows for sure, because the derivative is 0 and the step was very small, that this is the local maximum of this function. And then we're going to fit a 4th degree polynomial through the last 3 points, or the closest 3 points. This deviation is now too far from the cubic approximation vertically, so we use these 3 points. Would not have mattered, because whichever 3 points I pick, we get, of course, the exact 4th degree polynomial that the function actually is. Now we want to find a minimum next to this maximum, and we go in the direction where that minimum is the deepest. So the prediction is that there will be a minimum here which is deeper than that minimum. So we go this way, and we do that by jumping directly to the predicted minimum, which happens to be exactly in the minimum. And that is a good test, because that means that now we found another extreme, this minimum, and therefore we want to immediately fit another 4th degree polynomial through that. But I don't have 3 points. I need 3 points to fit a 4th degree polynomial. And this whole day I've been working on collecting those 3 points. So what happens is that now it says, well, we have to start over with some approximation. And we begin with the new local minimum plus the nearest point that I already have, which then gives this approximation. Ignore the parabola. And well, that's the only points we have, so there's no third point. So we need to get an extra sample. So what it does then is says, okay, based on these 2 points, the scale is this distance. The scale is then the change. I mean, the step that we can make that more or less, you know, gives a reasonable change, but not too far. We step that same distance to the right, and then we get at 5.6. Somewhere here, I guess, or well, should have been here somewhere. And the algorithm explains how we got there. So we need an extra sample, and we are just keep going in the same direction after we found no local extremes in the 4th degree. Sorry, in the all those curves are going up. Yeah, so there's no sensible thing to jump to. So if now I press space, I would like this point here to appear, and then use those 3 points to fit my 4th degree polynomial. But it crashes. And the problem here is that the number of samples within the scale range, the scale range being 10% larger than the scale itself, though this was the scale, the 10% larger should include both 1 and 0.6, which is not visible, but okay. So it should have been 2 points. We are not counting the extreme itself. Well, you've only found one of them, so that's wrong. So I'm going to set a breakpoint here, and then rerun the program, and then this is the third time that we get here, but you can also see it from that point. So I'm just going to run it, yes. Wait till we get in a breakpoint, might as well, oh no, I pressed, sorry, I have to start over. I pressed the key on the other window. Actually, I wanted to set a breakpoint somewhere else. Let's set a breakpoint at 189 instead of there. Just start or whatever. So now we see that it was entered with this value. So I can continue. And then the second time we have the 4.1, and then you can continue again. This is the third time, and now you see that that is the value that we had the last time as well, for the call that we want to debug. So we just asked for extra data, so the state should be equal to something else than this, namely need extra sample. So the scale value should be the difference between 1.1 and 5. So about this distance. So that this was 4.17 was my calculator. 4.17 minus, and this is 2.7. 2.7 is 1.47. 1.47, yep. So that's correct. The critical point is of course the 4.169 something. Now we're going to find those samples. Okay, the local extreme index. Now we did insert the extra data at the end, so the current the history, hopefully I can print that here. The history contains, this is uninitialized, so the last one is this one, 5.6. So the last one is 0.6 that is added here. And then the previous one is the minimum at 4.17, and this is 2.7. But that one is way further back in the history. And we get 4, 3, 2, and then 1. So you see those in the history. This is the last one added. This is 0.5, the minimum. And then you have to go back. There it is. So that's the second one. Yeah. So this is number 0, and this is number 1.1, and you have 2, 3, 4, 5 is the minimum, and 6, and we want to use 5, 6, and 1. Therefore, oh yeah, and current is 6, so that is this one, the last one. Index is a bit vague. It's actually the number of counts backwards from current. So we want to set this to 1, so that 1 before current is the extreme, the local extreme. So it should be 1. Now we start with I is 0 because we are going to run over all samples. So we just start here, which is, sorry, we not start here. We start here because this I counts back from current. So if I is 0, then actually you're going to use current, which is this one. And 0 is unequal 1, so this is not a local extreme. It's that one. So let's see if indeed we got the right sample. Yep, that's the 5.6, the extra data thing. And oh, interesting. I'm comparing that with an uninitialized value. Haha. Before I did this always at the first case. It's unlikely to be equal, right? It's not equal. I have to initialize this, so let me immediately do that before I forget that. Mm. 268. 268. That was already null. So this is not equal. Then we calculate the distance to the critical point, and that should be equal to the scale, right? Because this point was put scale distance from the critical point to begin with. So dist is 2 something, no, 1.46. Okay, scale value should be the same. Yep. So it's definitely larger than thousands of that because it's equal, and also less than 1.1. So this is true. And therefore we add 0.6 basically to the usable samples. Okay, maybe this is going wrong. I was trying to get a number of relevant samples at 2. I think that it must be, but it is no longer. Oh, it's 1. Yeah. Oh yeah. Yeah. I get it. This is again. Wait a minute. Okay, I don't think it's very much of a problem right now. Apparently, where did I get this from? From the history, huh? Just current. My problem is that this should be relevant, but it isn't. So we have only one relevant sample. I don't need this one to be relevant though. Okay, so all I want is that we also add 0.1 now. So I is now 1, which is not less than the number of relevant samples. Therefore we immediately stop. And then it prints 1. Now it prints it. Oh, it prints it already. Oh, it prints it already. Okay, yeah. Maybe I should just print it later then, because it's going to be increased, I think. It's definitely going to be increased now. That was the confusion. So if we do this, then we get I'm adding current. What the bullshit is that? I'm so confused. This is the we just added this one. I think this line is assuming that I added the approximation sample already. It says 0.1. Then why would I not have added that one? I think that's also not good. It should never happen, this. Okay, back to drawing board. 316. Yeah, this should never happen. I think. Okay. Let's keep going. So the problem is again that I never get here. It's unbelievable. And all that suffering because I wanted to avoid co-duplication of this these 4 lines or something. Yeah, 3 lines. Well, it seems the same assert, but now we have 2 and we have the correct points. This thing has no zeros. I think it was just a coincidence that we ran into this assert as well. I mean, with completely wrong points and stuff. But now we definitely have the right approximation, and it has no extremes. So then it tries to do something for which it needs to know a direction or something. Right, the next call to find extreme will use this local extreme and the W value that we return as the 2 samples for the cubic. Then we are only interested in extremes in the same direction as H direction. H direction should still be uninitialized. Yeah, good question. I think we already came here before and then it was set, and now we come here again. So yeah, now it's not none. It probably has the same value already. What's a book? It keeps asserting. I'm not getting past that point anymore. Oh, assertion false fields. Oh, that's just not implemented. Yeah, what to do now? Okay, that was pretty much expected then. Yeah, so I would say that it is okay to add it here. It was already handled. Everything was handled. So this is not a problem. Hello, Roy. Thanks for answering, but it's unlikely that this guy is still there. So I was asked a long time ago. A very long time ago. Yeah, me neither. It's a bit stupid that there are no timestamps. I just want my graphics to update at this point. I don't know what's going on anymore. Okay, man, thanks. I should go make dinner though. Yeah, maybe it's time for a break as well. Kind of a milestone that now we entered this exit this analog stream without a 30. Wow. Trying to clean out this part because we should do something when it is disconnected. but or do we? Yeah, wait a minute. No, that's correct. Actually, it's correct. It is correct. Get nearest sample. Get the nearest sample relative to after adding it. Yeah. I guess. Okay, and then reset the history. Add nearest sample and that. Update scale. Did not the same as what I did somewhere else, and then I added something. Yeah. And I removed it again, apparently. Code duplication. See, this whole block is the same. Horrible. It should make a new function called handle disconnect or something. This is part of update approximation. I do one or the other, and then update the scale, and depending on that, well, if it gets disconnected, we have to do something. And I have to do that above there as well, or I could just call this directly. Maybe just call update approximation. And then assume that, or make sure that this is not true. So then we would do this as well, and then already have that code. So instead of doing this, I could indeed just call update approximation, because now it's using this recurrent again, so I can do that. Update local extreme scale is recurrent, which is done here. And this is also the same. Looks like it. While if we just drop out here, then I update the energy, which is also not a bad thing. I can set state to something else, so I definitely don't want to enter here. And then we call update approximation. Ta-da! So I should drop out. I should drop out, and then I want to go here, and I want this to be false. Approximation should not point to the thing on the stack. What? Yeah, no. Well, that's not the stack. To the element. That's why it was on the stack. Now I get it. No, never mind. So this should be false, I said, which means that not first call. So first call should be false. So last region should not be unknown. That probably isn't anyway. So I can just drop out. What about, I'm just gonna assert before I drop out. I think it probably still holds anyway. Yes, we got past this point. So now 6 was added, and we have a new approximation now, which is using 5 and 6. Because the fourth degree polynomial isn't even drawn. But we still tried it, right? Fitting fourth degree polynomial, yeah. And then it has no zeros, therefore we just return third holds, explore to the right, 4.5, and update of the kinetic energy. And then indeed we call update approximation now, which indeed calls update local extreme with indeed 5.6. Which gives us a huge, what? Oh no, it's, I'm looking wrong. It does not give a scale update at all, actually. The sample is ignored because it's not fitting our approximation. What? Guess that was the old approximation. But a cubic through 1 and 5 does not match 6. Therefore 6 is not added. Instead we return disconnected because it doesn't fit the previous one. Then the scale is reset, history is reset. We add the 2 points, that is the new point at 5.6 and the nearest one. So this was the newest, and we add the nearest one, which is this one. And we start a new approximation, and this is the new approximation. Now going to 5 and 6, this time matching 6, and well, basically having dropped 1 as a part of the approximation. So my scale becomes 1.46. Well, okay. And so I have a new cubic, and find extreme does not find an extreme. Find extreme in this cubic. So there's 2 extremes, this one and that one. But we demanded that the extreme was on the right. And we're looking for a maximum. So the maximum is here and it's not on the right of 5. So then all we can do is keep going in that direction. And that's what we do. We go to 7.1. Not a big step, but we are careful. Now we are there. This is still not more than the current energy. But I'm seeing a rejected here. No, I don't know. In the graph it looks like it did not use too much, but apparently it did. Maybe the energy level wasn't updated already, something. Too much energy used, aborting going to the right, which means then we should jump back to the best minimum at 4.17. Change horizontal direction to the left. But now explored is left and right. Well, that's now the case. We're still going to the left, and the reason we go to the left anyway is because you did not explore this minimum yet. Minimum is only counted as a true minimum if the minimum left and right, if it exists, is lower. So we must find out if this one is lower or not. Ridiculously enough, we go to 2.7, which is exactly this in 0.1. Could be kidding me. 8 is on top of 0.1. What a waste of CPU. And I even have one sample now? Really? I mean, I already have this extreme. Might as well jump to there. Oh, this is a waste. So it's finding this maximum again? Well, or not. Now we assert again. Shouldn't you always move towards the critical point when this isn't a found local extreme, and away from it when it is already found? Okay, interesting. So we want to go to minus 0.2. Why the hell would we want it? Are we already going to a minimum? Huh, what? Okay, then where does this minus 0.2 come from? What's this one? Should keep going step. Oh. And why do we keep going? Because you couldn't find a maximum on the right. Ahaha, but that's wrong. This should have been left now. You are going to the left again. Interesting. Yeah, just the age restriction was not updated. So we are here, we are switching age direction to the left, but restriction is still set to the right. And we want to look for a maximum. And we don't see the maximum because the restriction says only look at the left. And because we don't find it, it thinks that it doesn't exist in that direction, right? So it thinks like it's going up and up and up and there is no extreme. And then the only thing to do is just keep going until you get over the energy. So it just makes steps. So it makes steps from, well, I don't know where it came from. We jumped here to 5, yeah, back, and then we step to 8. Then we continue to step to 9, and it says there is no maximum because it's on the wrong side. And then we just make another step. And then we assert, rightfully, because we jumped over the assert. We jumped over the maximum. Good assert. Pets assert on the head. But I'm just going to stop, I think, and eat, make dinner right now. I'll be back later.